This concept video we're going to be discussing formulas that link x, y, theta, and r. And maybe I should change that right away. We're not really going to develop these. We're going to just discuss these. These formulas were developed in some of the previous videos. So if you'd like to see where these things come from, check out the videos from Learning Target 1. And that's from changing polar coordinates into rectangular coordinates and vice versa. So I'll just remind you of a few of those equations. So we've got x is equal to r cosine theta, y is equal to r sine theta, and then we also developed some formulas to go from rectangular to polar, and so we've got r squared is equal to x squared plus y squared. This could also be r is equal to the square root of x squared plus y squared. And by the way, I maybe should do that here with these two. The cosine of theta, if we just divided by r here, would be x over r. And then the sine of theta could be also y over r. There's one more here for this one, and that would be that theta is equal to the inverse tangent of y over x. You don't see this one a whole lot, but sometimes you do. Or you could write the tangent of theta equals y over x, and you might see this one here and there. So all we're doing here is we're trying to link x, y, r, and theta. Usually you're just going to do three of those together. So for instance, x, r, and theta are here. What we're going to use to help us to change between polar and rectangular and back and forth for equations is we're going to use the principle of substitution. So if you ever see r cosine theta and you want to make it an x, you can. If you see r sine theta anywhere and you want to make it a y, you can. So we can take out that part of an equation and substitute in whatever it's equal to. There's a few hints for this, so I'll put those over here on the right hand side. Not one thing is going to work every time, so it's kind of similar to verifying trigonometric identities if you're thinking back to an earlier time. So one of the hints is to try to solve for r. That can work sometimes. If you can solve for r, you can start replacing it with things, and you also might be able to get something like r cosine theta, r sine theta, something like that. You could try to divide or multiply by r. If you can do that, sometimes you'll wind up with r squared, x squared plus y squared. You'll end up canceling the r out, or you'll wind up with like r sine theta or something like that. So that can work sometimes. The next thing is to get r or r squared by itself. So we'll try to solve, that's kind of the same thing as this hint up here, try to solve for r. Or, I mean, if it's still not solved for, you can still get it by itself. So if you had like r cosine theta plus r squared, that would work. R squared would be kind of by itself on it's not just by itself on one side of the equation, but at least it's isolated, separated, it's its own term, I guess is what I mean to say. So you can try that. And you can also look for r cosine theta or look for r sine theta. Those are easy ones. So we can take something that seems pretty complicated like r sine theta or r cosine theta and change it out for x or y. Remember that when you're changing between and converting between these equations, you're going to make some mistakes here and there. That's totally and completely normal. Really, the only way to get a handle on this is just to practice them, and you'll start to see more how you can develop some of these by using some algebra tools.